gives me immense pleasure to welcome you all to this wonderful celebration of Pi Day, a day that celebrates the beauty of physics, mathematics and scientific discovery. Today's program is filled with exciting events, informative speeches and engaging activities that highlights the importance of science in our daily lives. So, without any further delay, let us begin our program. Let's start this auspicious occasion by invoking the blessings of Almighty. A warm welcome sets the tone for every successful event. Now, I invite Chhatrapati Kumaran to deliver the welcome address and formally welcome the gathering.
Good morning and a warm welcome to all present here today. I am glad to welcome our chairman Dr. V. Kasimai, who is a guiding light in our journey. And I am also glad to welcome our director Mr. K. J. Kishore Kumar, who is extremely supportive at every step. And I am also glad to welcome our principal Mrs. S. Jyoti Lakshmi, whose tireless efforts motivate us every day. I am privileged to welcome respected dignitaries, proud parents, hardworking teachers and my dear friends in the grand occasion of Pi Day. Pi Day is celebrated on March 14 because of the constant value of pi 3.14. This day is not only special for mathematics but also for physics. It is celebrated on the birthday of the greatest physicist the world has ever known, Albert Einstein. Thank you everyone.
As we celebrate Pi Day, we mark this occasion with a joyful moment of distributing food.
Good morning. This is Hasni going to talk about this special day. Do you know why we have gathered here? Yeah, it's the Pi Day. Pi is a fascinating number that links mathematics with physics and helps us to understand many circular patterns that we see in nature and science. March 14 is celebrated as a Pi Day. Do you know why? It is because the date 314 represents the first three digits of pi, which is 3.14. The concept of pi has been known for thousands of years. In ancient civilizations like Babylonians and Egyptians used approximate value of pi while calculating the circles. Later, the Greek mathematician Archimedes was the first to calculate accurate value of pi while measuring circles. Applications of pi. The pi is used in construction and architecture. Engineers use pi while designing circular buildings, pipes, tunnels and domes. Computer and technology. Pi is used in computer graphics and animations. Space research. Scientists use pi while studying the movement of satellites and planets. And an interesting fact about pi is that its digits never end and never repeat. Even with the modern supercomputers, scientists were discovering many digits about pi. Thank you.
As we celebrate Pi Day, we also remember one of the greatest scientists, Albert Einstein. Now I invite Sudeep to deliver a speech about Albert Einstein.
Morning respected dignitaries, dear parents and my dear friends. Today is not only Pi Day, it is also special for another thing. Do you know what it is?
Albert Einstein's birthday.
Yes, you are correct. It's birthday of one of the greatest scientists in the entire history of universe, Albert Einstein. Albert Einstein was born on March 14, 1879, the day which the whole world celebrates as Pi Day. At his young age, he was a very curious and imaginative child who would often ask questions about how things work. Albert Einstein was a brilliant physicist who changed the way we understand this universe. Albert Einstein was not only a brilliant physicist, he is also a passionate musician. Music played a very important role in his life. Whenever Einstein faced difficulties in solving physical problems, he would often pick out his violin and start playing music. Music gives him clarity of thinking. This shows how music helped him his discoveries. Albert Einstein was died on April 18, 1955. After his death, every scientist was fascinated by his brain information. Fascinated by his brain information. Do you know why I am repeating this word fascinated? Before the explanation, let me ask you parents a question. Do you know what is the average weight of human brain? Any parent? Yes, you're correct, ma'am. 1300 grams. That 1300 grams is for men. For female, it's 1200 grams. Do you know why it's 100 grams lesser than a male brain? Because as much the weight is less for your brain, the creativity and thinkingness will be high. Thus, the women's have very creative thinking, like cooking, doing rangoli, I believe. But Einstein brain also the weight is same as women's brain. His brain's weight was 1250 grams. This made him as the greatest scientist in the entire universe. So on this Pi Day, let us stay curious, let us study maths, and let us be attractive with Pi and Einstein. Who knows the next discoveries from one of us. Thank you.
அன்பான பெற்றோர்களுக்கு என் இனிய காலை வணக்கம். இன்று நாம் கொண்டாட போவது பை டே. பை டே இஸ் an fascinating day and also we are celebrating Albert Einstein's birthday. Can you guess why we are celebrating? 1789 ஐன்ஸ்டைன் பிறந்தார். இந்த நாளை பிரமாதமாக கொண்டாடுவோம். நன்றி.
அனைவருக்கும் என் இனிய காலை வணக்கங்கள். இன்று மார்ச் 14ஆம் தேதி நாம் உலகில் உள்ள அனைவரும் பை தினம் கொண்டாடுகிறார்கள். இந்த நாளுக்கும் பையின் மதிப்புக்கும் ஒரு ஒற்றுமை இருக்கிறது. ஏனென்றால் பையின் மதிப்பு 3.14 ஆகும். அதுபோல இன்றைய தேதி 3ஆம் மாதம் 14ஆம் தேதி ஆகும். அது மட்டும் அல்லாமல் இது சரியாக 1:59 நிமிடம் கொண்டாடப்படுகிறது. ஏனென்றால் பையின் முழுமையான மதிப்பு 3.14159 ஆகும். முடிவற்ற வேகம். பையின் புள்ளிக்கு பிறகு கோடிக்கணக்கான எண்கள் தொடர்ந்து வந்து கொண்டே இருக்கிறது. அதுபோல் நம் கற்கும் திறனும் தொடர்ந்து வளர்ந்து கொண்டே வர வேண்டும். அதுபோல ஒரு சிறிய வளையல் முதல் வானில் இருக்கும் விண்கோள் வரை இந்த பை இருக்கிறது. இந்த பை என்பது புத்தகத்தில் பார்க்கும் எண் அல்ல, இது நம் இயற்கையில் சந்திக்கும் விஷயங்கள். அது மட்டுமல்லாமல் இன்று உலகில் தலை சிறந்த விஞ்ஞானி ஆல்பர்ட் ஐன்ஸ்டீன் பிறந்த நாளாகும். அது கணிதமும் அறிவியலும் ஒன்றிணைந்து இந்த நாளை சங்கமிக்கும். நன்றி.
Now I welcome the students for a maths skit.
Pi, it's 3.14. It's a constant value.
Why pi has 3.14 as a constant value?
I really don't know, bro. Next is maths period. Let's ask yourself.
Okay. Sir.
Good morning, students. Please be seated.
Sir, I have a doubt. Sir, what is pi?
Pi is a constant value 3.14, approximately 22 by 7.
Why, sir, it's always constant?
Come, we shall go to ground and explain it clearly. The value is 11.33. Students, got it? Now let's measure time. Diameter is 3.6. Now, by dividing these both values, we get 3.14. This is approximately equal to pi 22 by 7. Now, we shall repeat it for time also. The value is 5.665. Circumference is 5.665.
Here comes the interesting segment of our program, the mathematical activity. Wait, it's not for students, but for parents.
A very pleasant morning to one and all gathered here. Since today is Pi Day, we thought we could test something special today.
Don't worry, parents, it's a fun challenge, so please enjoy it.
What value have you got, ma'am? 20.11. So this parent has got a value, and this parent, what value have you got, ma'am? 40.3. So both parent has got different values, but both got the same answer, 3.14. This shows that pi is a constant value. Thank you.
Here comes a special moment of dream coming true. We are glad to invite one of the greatest physicists, Albert Einstein.
Today I am very happy to be here. I invite our director sir and principal ma'am on stage to join this great occasion. It is they who made our dreams come true. Let us invite them.
Now, I invite Anushka and Samiksha to have an intellectual conversation on inventions of Albert Einstein.
And that's why this process is called as mechanification. Later, you'll get dash from your body. Seems interesting, right? Okay, imagine if the black hole comes near to the Earth.
Once lived a child who was remarked for his strange behavior and was pricked by the words, "What a funny shaped head."
Hey fool! He's so slow. What's wrong with this child? But later on, that same child was prized for his incredible IQ. Can you guess your parents? Oh yeah, it's Albert Einstein. And this is Anushka, Samiksha from grade 12 Florentina to get you into the world of Albert Einstein. I hope you are all familiar with his brain's IQ, which brought numerous innovations and discoveries to our lives. So let's get into some of them to make the session more interesting. Let's get started. E is equal to mc squared. What idea flashed your mind when you hear to this formula? A torturing equation? No, it's the foundation of our lives. Everything that has mass can generate enormous amount of energy than you expect. How is it possible? It can be done by this formula. Here you can notice that energy is directly related to mass. That is, the energy that a single apple has is equal to the energy that this whole school needs per day. How? It's hard to believe, but that's the fact. It can be done by deep analysis. So, what's next? Photoelectric effect. This is the discovery of Albert Einstein which brought home his Nobel Prize. But what is photo here? Photo here refers to light, which contains photon. When this photon with a certain frequency strikes a metal like this, makes the electron energetic and makes them to jump out of excitement. As you know, moving electrons produce electricity. And this is the base of various modern applications like high-tech cameras, solar panels, and many more. Now let's get into the next topic. Geostationary satellites, the theory of relativity. Geostationary satellite. Now, focus our hands. What do you observe? Notice our hands move parallel to each other and never varies. And this is the key concept of geostationary satellite, which makes our Indian satellite to stay above all landscape, stay still forever. Have you ever wondered why the satellites are not being attracted by the Earth's gravity? A bit confusing, but the answer is given by this theory of relativity. The Earth too possesses a pushing force called relative gravity, which makes the satellite to move along with the Earth at a distance of 35,786 kilometers from our equator. You see, that line is that orbit where our satellites the black hole. Have you ever wondered what would happen if you get into a black hole? Simi, what's black hole? The whole universe is full of stars. Even our sun is a star. When a star loses its energy, it bursts and gives rise to a strong magnetic pull called black hole. It is so strong that even a light can't escape its pull. So now say me, what would happen if you get into a black hole? Have you ever tried spaghetti? Yeah, it's a type of noodles, right? Exactly. When you get into a black hole, your legs stretch, elongate, and becomes thin, just like spaghetti. And that's why this process is called as spaghettification. Later, your legs detach from your body. Seems interesting, right? Okay, imagine if the black hole comes near to the Earth. The Earth would disappear in seconds. But don't worry, the nearest black hole to the Earth is about 1,560 light years away, which takes 27.5 million years to cross by our rock here. As a conclusion, these are all just a pearl in a deep ocean. All the pearls of Albert Einstein cannot be explored in just 5 minutes. Now, the most vital moment has come. We have made a video for you to get you deep into the Albert Einstein's world.
A theoretical in its nature. It is now we are experiencing its application. Now I invite Nityashri and Nivedashri to deliver a speech on research.
All enjoyed the games and skills, and now let's jump into the theory part. And today I'm going to explain to you all the most interesting and a curious concept of supermassive black hole based on the research papers done by Hino Velke from Netherlands. The main abstract of this research paper was that the supermassive black holes are the unique compact object located at the center of the galaxy. And this paper reviews the formation mechanisms, observational evidences, and the astrophysical importance of supermassive black holes. What is a supermassive black hole? The black holes are the most extreme predictions of Einstein's theory. Among different types of black holes, these supermassive black holes are the largest and the most powerful one in the universe. And many astronomical theories state that supermassive black holes present in each galaxy. For example, our own Milky Way galaxy contains its own black hole known as Sagittarius A, which mass would ranges from 4 million to billions times of the Sun. Formation of supermassive black holes. This formation of supermassive black holes remains one of the biggest questions in the astronomical field. There are several theories proposed for this formation, and in this research paper, there are two important theories proposed for this formation. And the first theory states that the supermassive black holes are formed from the collapsing and the merging of stellar masses black holes leading to this formation. And the second theory states that the gas clouds around these galaxies collapse and interlink with each other due to the high gravitational field of the black hole leading to this huge massive thing. Physical properties of supermassive black holes. Supermassive black holes contain various physical properties such as its masses would range from millions to billion times of the normal black hole or sun. And it contains an even horizon or a ring around it, nothing can escape beyond it. And there's a super interesting process taking place in a black hole, and that's known as accretion process. When a thing or a matter falls towards a black hole, it starts rotating around it in a high speed due to the friction in the disk, and it's known as accretion disk. Role of supermassive black hole in the galactic evolutions. It has a great relationship between supermassive black holes and the galaxies. Yes, when the accretion process takes place, it leads to evolution of great energies and radiations out of it. And this leads to the formation of stars and galaxies. Observational evidences. And there are various observational evidences for the presence of supermassive black hole. And there are two interesting evidences in this research papers. One of the most important was the motion of stars around black hole. And the second most important factor was the motion of gas clouds around the black hole. Yes, when a black hole is formed, the stars and the gas clouds around it starts to move at a high speed. Through that, we could understand a new supermassive black hole was formed in our galaxy. And as a conclusion, I hope you all understood the concept of supermassive black hole based on the research papers done by Hero Felke. Thank you.
I am here to explain the most interesting topic of stellar black holes. A stellar black hole is the black holes formed due to the gravitational collapse of a massive star at the end of their life cycle. Formation of the stellar black holes. The stellar black holes are formed when the fuels are exhausted. It undergoes a gravitational collapse in which the entire mass is collapsed, but the remaining core is larger enough to form a black hole instead of a neutron star. The physical properties of a black hole. The black hole has masses of about 5 to 100 solar masses, but the black hole which has masses greater than 500 solar masses forms a stellar black hole. The anatomy of the stellar black holes. The stellar black holes has an anatomy of event horizon, a boundary from which nothing can escape, an accretion disk, an extremely hot rotating disk of gas which has high X-ray radiations. A corona, an extremely hot plasma region of the black hole which has high energy radiations. The observational evidences of the stellar black hole. These stellar black holes can be detected using the X-ray binary system and gravitational waves. By detecting those X-ray waves and gravitational waves, we can predict the presence of the black holes. Journey to the edge of the black hole. It is something most interesting. At the edge of the black hole, there is the event horizon, a place where the gravity slows the time at the black hole. The stellar black hole in our galaxy. Our Milky Way galaxy has about 100 million to 1 billion stellar black holes. The first confirmed stellar black hole is Cygnus X1, then V616 monoceratosis. The astrophysical importance of the stellar black holes. The stellar black holes provides various information about Einstein's general theory of relativity. It also provides information about stellar evolutions. It emits lot of X-ray radiations and gravitational waves, which help the scientists to study extreme physics. I hope you might have a clear idea about the stellar black holes. Thank you.
Hello to one and all gathered here. Today, we are going to study about the softwares which are used to research black holes. Okay, now let us dive deep into the most powerful and darkest laboratories of cosmos called black holes. Universe has been hiding hundreds of secrets for millions of years, which are called black holes. Now, let us start our softwares. The first software which is used to research about black hole is CASA, Common Astronomy Software Application. This is built on the core of C and C++. It has a robust computation skills. Distance and size estimation of black holes is done through CASA software. Distance and size estimation process involves 4 steps. First, calculating the angular momentum of the particular celestial object. Then, collecting out the raw radio waves which are obtained through telescopes from the cosmos. Then, geometrical calculation is made by applying distance into angular size formula. At last, a result interpretation is made by scientists. Calibration and imaging process of CASA. Calibration process involves in removing all those atmospheric errors, scientific errors, and instrumental errors which are obtained from telescopes. Imaging process. Imaging process of CASA involves in uploading all those raw radio waves which are obtained from telescope into the CASA software in order to produce a clear sky image. Next comes HESOFT software. HESOFT, High Astrophysics Package. Now, the calibration and imaging process of HESOFT. Calibration of HESOFT involves in computing all those X-rays and removing all those detectors and instrumental errors which are in the X-rays obtained through telescope. An imaging process of HESOFT involves in applying the corrected photon events into the heat of software in order to produce a clear 2D sky image. Here, the time and energy corrections of photon events are applied, which are defined as calculating the number of photons which are entered into the telescope and calculating the amount of energy contained in them. Next comes SAS software. SAS, it has a clear, unique feature of automatic calibration and imaging process. Once if the data is entered into the software, it computes itself and removes the detector and atmospheric errors in order to produce a clear 2D sky image. Thank you.
Very pleasant morning all. Now let's get started with the topic of astrophysical software. As he said, she mentioned many of them. But when we also talk about the integrated softwares or ideal softwares, but let me just tell you that looking at the title itself, you guys will be wondering, only the scientists who wear lab coats and have very busy hair would understand what the things which I'm going to say. But don't worry, I won't make this sound like a physics lecture that makes everyone to wonder and question your life choices. Let's get started. First of all, let's get started with the basics. Astronomers use extremely powerful telescopes to observe stars, galaxies, black holes, and other dynamic phenomena in the universe. And when the telescopes observe a black hole, it won't send you messages like, "Congratulations, yes, you find some sort of black hole in the universe," but it sends huge amount of data signals. And when I say huge, it's not some sort of quality or quantity which our normal laptops could handle. It's very huge that at most our normal laptops could do is just stare at those signals and could say, "Okay, I'm not doing this. I would never be able to handle such amount of quantities," and it can be retired. But we have supercomputers especially designed for such processes to handle the data management and software handling in astrophysics department. Those softwares not only help in the data conversion. First of all, we need those raw data signals to get converted into something meaningful, useful, unique, and understandable. For that, we use softwares. As you said, we have softwares like Keysoft, SAS, Astrophy, and many of them. Those softwares help in the conversion of data signals into scientific terms. Without the conversion, all those data signals would just look like some sort of very confusing spreadsheets that the universe created by own. Okay, then we have those softwares actual physics. So what I'm going to say is, those scientists they just zoom in some sort of pixels and get to decode the entire universe and the mystery happening inside the universe. But when I try to zoom in the pixels of my photo, all I get to realize is why I shouldn't touch the photography skills of mine. Now let's not talk about it. I have very bad photography skills. Now let's move on to the next slide. We have some softwares, despite being powerful, those softwares have, let's say, some personality issues. First we have Keysoft. It is a powerful software as well, but the process which is now disturbing the scientists is installation. It has large installation process, which means it feels less like installing software and more like doing some sort of complicated mathematical integral problems. Then we have X-Ray. It is powerful as well, but the thing is, if you choose one wrong model, then you'll get very creatively wrong answers. Then we have SIAS or CIMO and SAS software. Both softwares are mission specific, but the thing is, one program works for one telescope, another program works for another telescope, and suddenly the scientist needs 5 different programs to analyze one single data set, which is a complicated process as well, because mission specific telescope don't support multiple telescopes mission. Then last we have Aachian Pi. This is a flexible software, but the thing is, it assumes that you know Python, because that is when the scientist can realize, wait, I study physics, not computer science, and I'm not a Python programmer. So this is the problem with the Aachian Pi software. Then this is the graph, and as I said, they're now representing the data as they're collected so far in graphical format, because they get to visually analyze and understand what is wrong with the object or what kind of object they're been dealing with so far. But the important part is, not all the graphs that they have plotted so far are not perfectly exact, which means they do have some errors. Now look at the vertical lines connected to each and every point over here. Those represent the error bars. Error bars are something which shows the range of the actual value which it could lie. For example, let's take a point lying in the brightness, or which represents the brightness in a graph, and if it has error bars, we get to know how much of uncertainty exists in that point. Those uncertainties may be due to the instrumental noises, calibration errors, and other limited telescope resolutions. Basically, it's just the graph saying, I did my best estimate, but we all know that the universe is still unpredictable. Let's summarize the key challenges. First, we have learning curves. Those are so steep that the beginning, the scientists start to analyze the data, but they will end up as like a philosopher questioning their life choices. They are so steep. Then we have command line interfaces. In these kind of softwares, they don't get to actually press some nice buttons of programs and coding, but they will send some command lines or comments and hope that the computer will understand. Sometimes it will work, but other times it's just a mess. It gives some kind of messages like errors detected. It is actually good that we get to know that some kind of error exists, but we don't actually get to know what the literal problem is. Then as I said, we have large installations, mission-specific tools, and model selection risk. As I said before, if we choose the wrong models, then we get very creatively wrong answers. And time investment, it takes more than 2 hours to just analyze what is wrong with that particular software. So we have some key features for a new integrated, oh my god, we got it is new integrated automatic astronomical analysis software. I was needed to write it too tiny in my hand. I'm sorry. So we have that integrated ideal software which could have none of the defects that we have in our current softwares. In this software, we have unified interface where the programmers or the scientist doesn't have to switch between programs to analyze multiple telescope missions, but also they do need to have some other processor like error estimation automatic thing, which is a future, but that they get to analyze the exact
excitement. I invite Latika and Sanju to conduct the connection game.
Now we are here to conduct a game, a technical game which is so interesting.
In this game, we have taken a set of images where you have to connect and find a technical term related to physics. If you know the answer, you can just raise your hand, and if the answer is correct, you will be rewarded with some gift parents. Can you guess what it is? Can you guess the second image what it is?
Right here.
Can you guess?
Parents.
If you know, just you can raise the answer.
It's the correct answer.
The light travel how far in a year?
Enter into individual colors.
Can you find?
This one explains how the light bends. Can you find parents? Radio. Yeah, it's correct. Sound waves. Radio is the correct answer. Radio is the electromagnetic wave which carries the signals through air. But it is easy. But actually, your answer is correct. It's radius.
Yes, the correct answer is magnetism. It's correct. Can you guess that? Correct.
Yeah, it's correct. It's the energy of in this that is electricity.
Electricity, yeah?
Yeah, it's correct.
It is actually a physics term.
Yes, ma'am, it's the correct answer.
You will find out the rules. You pick number.
இன்னைக்கு எல்லாரும் the celebration of Pi Day. Einstein நமக்கு ஞாபகம் வருது என்ன? ஐன்ஸ்டீன் சொன்ன உடனே நமக்கு டக்கு ஞாபகம் வருது. ஸோ அந்த ஐன்ஸ்டீன் வந்து ஃபர்ஸ்ட் ஆங்கிலத்தில் இருந்துச்சு அந்த கிராவிடேஷனல் ஃபோர்ஸ், நியூட்டன்ஸோட 3 laws, அதோட வளர்ச்சிகள் தான் நம்ம இப்போ இருக்கிற சோபிஸ்டிகேட்டடாக வாழ்ந்துட்டு இந்த விஷயங்கள் எல்லாம். அவரை நினைவு கூறும் வகையில் இன்னைக்கு நம்ம ஸ்கூலில் வந்து ஆர்கனைஸ் பண்ணுறோம் Pi Day celebration. இன்னைக்கு நம்ம பசங்க எடுத்த கிளாஸில் நிறைய பேர் அந்த பிளாக் ஹோல் பற்றி சொல்லியிருப்பாங்க. அவங்க black hole is a main research paper submitted by senior physician Stephen Hawking Alice our last research paper continues from the Einstein continuous research paper பண்ணுவாங்க. ஃபைனலாக அவர் சப்மிட் பண்ணிட்டு அதுக்கப்புறம் தான் அவர் இறங்குறாரு. அந்த ரிசர்ச் பேப்பரை நம்ம பசங்க வந்து தே ஜஸ்ட் ஸ்டடி அதை வந்து கொடுத்துருக்காங்க. இன்றைக்கி எடுத்த கிளாஸ் சப்ஜெக்ட்ஸ் டாபிக்ஸ்லாம் இருக்கு இல்லையா, இது எல்லாமே அவங்க புக்லேருந்து எடுத்துருக்காங்கன்னு எத்தனை பேர் நினைக்கிறீங்க? அவங்க +2 புக்கு படிக்கிறாங்க இல்லையா, +1 படிச்சிருப்பாங்க இல்லையா, அந்த புக்லேருந்து எடுத்த கண்டென்ட் எத்தனை பேர் நினைக்கிறீங்க? எதுவுமே கிடையாது. இது எல்லாமே அவங்க ரிசர்ச் பண்ணி அவங்களா பிளான் பண்ணி இந்த பேப்பரை வந்து ப்ரொடியூஸ் பண்ணாங்க. நம்மளை பொறுத்த வரைக்கும் மார்க்ஸ் அதெல்லாத்தையும் விட ஸ்கில், பசங்களுக்கு திறமை வந்து எவ்வளோ இருக்குது. இன்றைக்குரிய ப்ரோக்ராம் நல்லா இருந்தா எத்தனை பேர் ஹாப்பியாக இருக்கிறீங்க? அவங்களுக்கு தேங்க் பண்ணுவோமா? எனக்கு யாருமே இவங்க தான் ஆர்கனைஸ் பண்ணாங்க. இவங்க தான் அஜெண்டா பிளான் பண்ணாங்க. தே கிளியர்லி மேக் ஏ பிளேன். ஒரு 2 வந்து டெக்னிக்கல் கண்டென்ட் கொடுக்கணும், அடுத்து உங்களுக்கு ஒரு கேம் கொடுக்கணும், அடுத்து வேறு ஏதாவது டிஃபரெண்டான கண்டென்ட் கொடுக்கணும், கடைசியாக ஒரு கேம் கொடுக்கணும், சிறுசு முதல்ல உங்களுக்கு எடுத்து அனுப்பணும். தே ஹேவ் பிளான் வெரி வெல். அதே மாதிரி இவங்க இன்னைக்கு எடுத்த டாப்பிக்குக்கும் அவங்களுடைய சப்ஜெக்ட்டுக்கும் சம்மந்தமே இல்லை. புதுசாக ஒரு விஷயம் நம்ம சொன்னாலும் ஒரு விஷயத்தை வந்து அவங்களே ஃபைன் பண்ணி ரிசர்ச் பண்ணி அது சம்மந்தமான ஒரு எவ்வளோ கண்டென்ட் இதெல்லாமே அவங்க ப்ரிப்பேர் பண்ணது. வி ஹவ் நாட் ஜஸ்ட் கைட் தான். மற்றபடி அவங்க தான் எங்களை ஸ்டாஃப்ஸை அப்ரோச் பண்ணி பிரின்ஸிபல் அப்ரோச் பண்ணி அவங்க கண்டென்ட் கொடுத்து பண்ணதான் தவிர எங்கள் சைடில் இன்புட் கொடுத்து இப்படி பண்ண அப்படி பண்ண நாங்கள் சொல்லவே இல்லை. இதுதான் நமக்கு தேவை. பசங்களுக்கு திறமை தான் வேணும். இது நம்ம பசங்களுக்கு இயற்கையாகவே இருக்குது. நாங்களே ஸ்கூல் லெவலில் முடிச்சிருக்கலாம். உங்களுக்கு தெரியப்படுத்தணும், நீங்கள் தெரிஞ்சுக்கணும். அடுத்து ஏன்னா காலேஜுக்கு போகிறாங்க பசங்களுக்கு வந்து என்னதான் மார்க்ஸ் ஸ்கில்ஸ் இருந்தாலும் அவங்களுடைய திறமைக்கு எந்த ஃபீல்டில் கொண்டு போகலாம், இதுலேருந்து நீங்கள் ஒவ்வொருத்தருடைய கெப்பாசிட்டி தெரிஞ்சுக்கலாம், பையனோட இன்ட்ரெஸ்ட் எதில் இருக்குன்னு தெரிஞ்சுக்கலாம், அவங்களுக்கு என்ன மாதிரி காலேஜஸ் எப்படி கொண்டு போகிறன்றத நீங்கள் டிஸ்கஸ் பண்ணி சொல்கிறதுக்கும் ஃபோர்ஸ் பண்ணுறதுக்கும் டிஃப்ரென்ஸ் இருக்குல்ல. அந்த டிஃப்ரென்ஸ் வந்து நீங்கள் கொஞ்சம் புரிஞ்சுக்கணும். அதுக்காண்டி தான் மெயினாக கூப்பிட்டோம். தேங்க்யூ எவ்ரிஒன் ஃபார் கமிங்.
இதனோட நோக்கம் ஆல்பர்ட் ஐன்ஸ்டைனும் பை மட்டும் இல்லை, ஒரு ஃபங்க்ஷனையே ஆர்கனைஸ் பண்ணியிருக்கேன். ஒரு அகடமிக் பேஸ்டு ஃபங்க்ஷன் ஆர்கனைஸ் பண்ணுறது போரிங் இல்லாமல் அவங்கள வச்சுக்கிறதெல்லாம் வந்து இட்ஸ் நாட் எ ஈஸி ஜாப். நாங்கள் யாருமே கைட் பண்ணலை. யூ திங்க் அபவுட் ஹவு டு ஆர்கனைஸ் த ப்ரோக்ராம். ஸோ இது வந்து மேனேஜ்மெண்ட் ஸ்கில். ஏன் குழந்தை ஒரு மேனேஜ்மெண்ட் கோர்ஸ் போகுதுனோ இல்லை ஒரு ஆண்டர்ப்ரனர்ஷிப் எடுத்தாலும் ஒரு கிளைண்ட் எப்படி பண்ணணும், ஒரு ப்ரோக்ராம் எப்படி ஆர்கனைஸ் பண்ணணும், ஒரு காலேஜில் ஒரு ப்ரோக்ராம் கொடுத்தாங்கன்னா அங்கே லீடர்ஷிப் எடுத்து என் குழந்தை எப்படி பண்ணணுங்கிறதெல்லாம் நான் சொல்லி கொடுத்தா தானே வரும். பட் தே டாட் மீ. சொல்கிறதே தலைகளாக நான் சொன்னேன். தே அப்ரோச் மீ டெல்லிங் தட் மேம் எனக்கு இந்த டயர் வேணும், எனக்கு இந்த ரோலர் வேணும், எனக்கு இந்த டேப் வேணும். வாட் ஆர் யூ டூயிங் மேம்? வி ஆர் ரிசர்ச்சிங். ப்ளீஸ் டூ வாட் வி ஆஸ்க் ஃபார். ஜஸ்ட் மெட்டீரியல் ஃபெலிசிட்டேஷன் மட்டும்தான் சாரும் நானும் பண்ணுவேன். அப்ரூவல் வாங்கி சார் இது பண்ணுங்க மேம், என்ன பண்ணுமோ பண்ணட்டும். லெட் தெம் டூ. லெட் தெம் ஹேவ் த ஃப்ரீடம் ஆஃப் லேர்னிங். தப்பே பண்ணாலும் லெட் தெம் லேர்ன் ஃப்ரம் த மிஸ்டேக்ஸ் மேம். டோன்ட் டூ எனிதிங். தே ஆர் வெரி பிரேவ். பண்ணட்டும் மேம். தட் அப்ரூவல் ஹி ஹஸ் கிவன் மீ. இதில் ஏதாவது தப்பு பார்த்தீங்களா? ஸோ ஹேட்ஸ் ஆஃப் டு மை சில்ட்ரன். ஐ எம் வெரி ப்ரௌட் ஆஃப் மை சில்ட்ரன். இந்த மேனேஜ்மெண்ட் ஸ்கில்லோ இந்த ஆண்டர்ப்ரனர்ஷிப்பும் இருந்ததுன்னா they will survive anyway. So I don't want to give you only marks. I want to produce them as a perfect citizen and perfect fittest of the survivor. Thank you for coming. Thank you for coming.
Thank you for those inspiring words, sir. Thank you, ma'am. As we come to the final part of our program, it's time for us to show our gratitude. I invite Ritika to deliver the vote of thanks.
Pleasant morning all. It's my pleasure to propose the vote of thanks on this occasion of Pi Day. First and foremost, I express my heartfelt gratitude to our chairman, Dr. V. Kasimayan, for his constant guidance and encouragement. I sincerely thank to our director, Mr. K. Jaykishore Kumar, for his continuous support and inspiration. My sincere thanks to our principal, Mrs. S. Jyoti Lakshmi, whose motivation and make this event like this possible. I extend my gratitude to our dedicated teachers for their guidance and expressing this organizing like this. A special thanks to our respected dignitaries and beloved parents for their gracing and with your presence. I also appreciate our students who have participated and made this event lively and memorable. Thank you.
Good morning to all. So today I came for the Aachian International School for the Pi Day, that is the Einstein's birthday. So here I wondered about the students. They are presented the paper about the black hole. It is very much wonder about the more amount of topics we are interested, and they are conducted some games. So it will motivate our mind also to know about the astrophysics. So very good, ma. So you promote more. Okay. Hereafter there are so many functions we are conducted like this, means we are all very much motivated about these functions, and all the students are gathered here also motivated about astrophysics and that space research, everything. So it's very nice to see you all. So again and again we have come and meet the school like this, so much of many more organizing functions. Thank you.
வணக்கம். இன்றைக்கி ஆச்சி இன்டர்நேஷ்னல் ஸ்கூலில் ஆல்பர்ட் ஐன்ஸ்டீனோட பிறந்தநாள் விழா மிக சிறப்பாக கொண்டாடினாங்க. அது மேனேஜ்மெண்ட்டு நல்ல திறம்பட நடத்தியிருந்தாங்க. அதில் பிள்ளைங்களுக்கு வந்து அவங்களே நிறைய பேப்பர்ஸு அவங்களே ரிசர்ச் பேப்பர்ஸ் எல்லாம் எடுத்து பிளாக் ஹோல்டாக இருக்கட்டும், அஸ்ட்ராலஜி இதாக இருக்கட்டும், அந்த ஃபன் கேம்ஸாக இருக்கட்டும், எல்லாமே ரொம்ப சிறப்பாக பண்ணியிருந்தாங்க. அது ஸ்டூடெண்ட்ஸ் மத்தியில் அவங்களே ஒரு விழாவை எப்படி எடுத்து நடத்துறது, அதை எப்படி ஒரு அஜெண்டா ப்ரிப்பேர் பண்ணுறது, எதற்கப்புறம் எதை இது பண்ணுறது அப்படின்ற விஷயங்கள்லேருந்து ரொம்ப சௌகரியமாக பண்ணியிருந்தாங்க. இதுக்காக நான் இது பண்ண எல்லா பிள்ளைங்களுக்கும் நான் என்னோடய சார்பாக வாழ்த்துக்களையும் நன்றி தெரிவிச்சுக்கிறேன். இந்த மாதிரி அடிக்கடி எல்லா குழந்தைகளுக்கும் எல்லா இதுலேயும் நிறைய மோட்டிவேட் பண்ணுற அவங்க மேனேஜிங் டைரக்டருக்கும், அவங்க பிரின்ஸிபால் மேடத்துக்கும், மற்ற இதுக்கு இது பண்ண எல்லா ஸ்டாஃபுகளுக்கும் நான் என்னோடய வாழ்த்துக்களையும் நன்றியும் தெரிவிச்சுக்கிறேன்.
ப்ரோக்ராம் நல்லா இருந்துச்சு சார். இந்த மாதிரி ப்ரோக்ராம்லாம் பண்ணுறதுனால இவங்களுக்கு ஃப்யூச்சரில் நல்ல யூஸ்ஃபுல்லாக இருக்கும். தேங்க்யூ.
வணக்கம். இன்றைக்கி ஆல்பர்ட் ஐன்ஸ்டீனோட பிறந்தநாளை வச்சு நம்ம ஆச்சி பன்னாட்டு பள்ளியில் ஒரு சிறந்த நிகழ்ச்சி ஒன்று பண்ணியிருந்தாங்க. அதில் வந்து பிள்ளைங்க, ஸ்கூல் பள்ளி நிர்வாகம் எல்லாருமே சிறப்பாக பண்ணியிருந்தாங்க. இந்த நிகழ்ச்சி ஏற்பாடு செய்த பள்ளி நிர்வாகத்துக்கு பெற்றோர் சார்பாக என் சார்பாகவும் நன்றியையும் பாராட்டுகளையும் தெரிவித்துக் கொள்கிறேன்.
வணக்கம். என்னோடய பையன் ஆல்பர்ட் ஐன்ஸ்டீன் இது பண்ணதில் எனக்கு ரொம்ப பெருமையாக இருக்குது. நான் அதை எதிர்பார்க்கவே இல்லை. அவன் என்கிட்டையுமே சொல்லவே இல்லை. எனக்கு சர்ப்ரைஸாக இருந்துச்சு. உண்மையிலே இந்த ஆச்சி இன்டர்நேஷ்னலுக்கு நான் ரொம்ப கடமைப்பட்டிருக்கேன். என் பையன் இவ்வளோ தூரம் வந்ததுக்கு மெயின் காரணமே இந்த ஸ்கூல் தான். ரொம்ப சந்தோஷம். இன்னும் மேலும் மேலும் அவன் வளர்கிறதுக்கு நான் மிக்க நன்றி.